Okay, in this first video what I want to do is just remind you about the basics of what we talked about in year 12 many moons ago regarding stationary points. Remember, stationary points are points on curves where the gradient is 0. So for example, if I'm drawing a curve like this, I'll just draw a little curve here like this. That curve there has got several stationary points. As you can see at that point there, which is called a maximum point or a local maximum, if I was to draw a tangent there and I was to measure how steep that tangent was, we would say that the gradient of the tangent was equal to 0 because it's a flat line, it's got a 0 slope. So for a local max, if you remember, a local max, that means just in the region of this part of the curve, that's local. Then we say a local max dy by dx will be equal to 0. And that's very important for future reference. Now, it's not the only time where the gradient can be 0 on curves. So for example, if you look at that point there, that's what we call a local min. And once again, if you were to draw a tangent at that point there, the gradient of the tangent would be 0. Okay, and that would be a local min. So once again, a local min, the gradient would be equal to 0. And that's something we've seen in the past. In this particular picture, there is another stationary point, which is a local max, which is present right at the top up there. Again, tangent drawn there, and once again, local max dy by dx equals 0. However, there is a third type of stationary point, and this is known as a point of inflection, which we have seen, although we didn't do a lot of work on it. And that point of inflection can be seen in that situation, whereby you don't get a max or a min, you get this sort of setup like so, where at that point there, if I was to draw a tangent, the gradient of the tangent would be a flat line. It would be, once again, point of inflection. Let me just write this down. Once again, it would be a stationary point. So dy by dx would be equal to 0. Notice inflection sometimes is written with an x and sometimes it's written with a CT. It doesn't really matter. I think one's an American spelling, but I think either are acceptable. So you can see that there are various types of stationary points, and we've done some basic questions involving all types. Can I just remind you as well that inflection points are slightly more difficult because the inflection point could go like that, or you could, in some cases, have an inflection point. Let me just draw it over here. That looks like this and goes the other way. And that is also an inflection point, and you have to be able to distinguish between the two. Now, let me just follow up on the basics of that by saying, therefore, if you're trying to find stationary points, the key thing to remember is for any stationary point, doesn't matter what type it is, dy by dx will be equal to 0. That is the key thing that you need to know for stationary points. We then follow that up by saying, if you want to distinguish between them, if you want to work out which stationary point is which when you're doing a particular question, let me remind you of the technique, and then perhaps in another video I'll follow it up by showing you a reminder of the work we've done in year 12, and then in subsequent videos we'll have a look at some new techniques on stationary points for year 13 work. So d2y by dx squared, that's, remember, the second derivative. That's the first derivative. You work out the first derivative for a particular curve and then you work out the second derivative. If you don't remember how this works in practice, I'll show you in the next video, but the test for different stationary points was this. You work out d2y by dx squared. If the answer turns out to be positive, it's a local minimum point. That's the basic rule that we followed. If, when you work out d2y by dx squared, it turns out to be negative, then it's a local max. And what we saw in year 12 is if you work out d2y by dx squared and the answer was 0, we said it was going to be a point of inflection. Now, strictly speaking, even though this is what we saw in all the examples in year 12, this last statement is not technically correct, and I will refer to that in a future video when we start the year 13 work on stationary points. But at this moment, that in a nutshell is what you have done in year 12, and I'll stop the video at this point, and in the next video I'll do a very basic question which we did in year 12, which makes use of these principles, just to remind you what we did, and then in subsequent videos we'll take things a stage further.